Hello, and welcome back to AstroAwe. I'm your host, and tonight, we're venturing into the darkness. When you gaze up at the night sky, you see a canvas of serene beauty, a peaceful tapestry of twinkling lights. But that's just the surface. Beyond the beauty, the cosmos hides terrifying secrets. These aren't the monsters of fiction, they are real physical phenomena governed by the laws of physics, which makes them all the more frightening. The universe is a place of extremes, where the concepts of empty, crushing, and endless take on meanings that defy our terrestrial experience. Tonight, we're not just stargazing, we're embarking on a journey, a cosmic tour of the 10 most extreme and horrifying locations in the universe. We will travel to places where the laws of physics become a death sentence, where emptiness itself is a source of dread, and where forces beyond our comprehension shape reality in violent, cataclysmic ways. Prepare to have your perception of fear reshaped. Our first stop is a place defined not by what is there but by what isn't. Welcome to the Booty's Void. Imagine traveling for hundreds of millions of light years and seeing nothing. No shimmering galaxies, no nebulae, no stars, just an ocean of absolute unrelenting blackness. Discovered in 1981, this colossal region of space is so vast, so profoundly empty, that it defies our models of cosmic evolution. It's a spherical void nearly 330 million light-years in diameter. To put that in perspective, our own Milky Way galaxy is just 100,000 light-years across. You could fit thousands of galaxies like ours into this space, yet we've only found a mere 60. To be adrift in the Booty's Void would be the ultimate isolation. In every direction, for a span of distance your brain cannot truly process, there is only the deepest, purest black. Here, the grand cosmic web of galaxies, the very structure of the universe, has a hole torn through it. It is the abyss, staring back. From the terror of nothingness, we now journey to a place where something has become so powerful, it creates its own form of nothingness. We are approaching a black hole, the event horizon. This isn't a physical barrier you can touch, it's a threshold, a one-way door in space-time. It is the precise boundary around a black hole from which no information, no matter, not even light itself can ever escape. Imagine you're in a spaceship, approaching this cosmic waterfall. From a distance you see the light from distant stars bending around the black hole. As you get closer, the blackness ahead becomes absolute, a perfect circle of non-existence against the cosmos. The event horizon itself is invisible. You could drift across it without even noticing. One moment you're in the observable universe, the next you are irrevocably cut off. As you fall toward the singularity at the center, the gravitational pull on your feet would be exponentially stronger than the pull on your head. This tidal force would stretch your body, atom by atom, into a long, thin stream of plasma. Scientists call this spaghettification. The moment you cross the event horizon, your future contains only one destination: the singularity. Time and space warp so much that moving away becomes as impossible as traveling backward in time. All the information about what you were is, to an outside observer, lost forever. The event horizon is not just a point of no return, it is the point of no existence. Imagine taking a star more massive than our sun and crushing it down into a ball no larger than a city, the island of Manhattan. What you get is a neutron star, one of the densest objects in the universe. A sugar cube-sized piece would weigh about 100 million tons on Earth. That's roughly the weight of the entire human population, packed into a palm-sized cube. About 200 billion times Earth's gravity. You would be instantly flattened into a layer of atoms a few molecules thick. A marshmallow dropped from a meter would hit like 1,000 hydrogen bombs. Neutron stars are cosmic dynamos, spinning hundreds of times per second. That spin creates magnetic fields trillions of times stronger than Earth's. Those fields would rip atoms in your body apart from 1,000 miles away. The iron in your blood would be torn from your cells by that invisible force. These magnetized behemoths act like cosmic lighthouses. They shoot out twin beams of intense radiation from their magnetic poles. Beam 1, beam 2. If one beam sweeps across us as it rotates, we detect a pulsar. Being hit by a pulsar sweep would flash fry you and shred your DNA instantly. So, gravity that flattens you into a subatomic smear, a magnetic field that tears you apart from a distance, and beams of radiation that can incinerate across a solar system. A tiny city-sized sphere that packs more destructive power than we can imagine. So, back in 2004, while mapping the cosmic microwave background, the faint afterglow of the Big Bang, astronomers found something strange. There was this patch of sky, located in the direction of the constellation Eridanus, that was, well, unnaturally cold. And this wasn't just a small blip, it was a vast region, over 1 billion light-years across, significantly colder than the surrounding universe. This is the Eridanus supervoid, often just called the CMB cold spot. As photons from the CMB travel through this void, they lose energy, making them appear colder to our telescopes. The supervoid theory, while the most accepted, doesn't fully account for the sheer size and coldness of the spot, making it another statistical anomaly that really pushes the boundaries of our cosmological models. One of the most mind-bending theories is that the cold spot is not a void at all, but a bruise, a scar left on our universe from a collision with another universe. In the context of the multiverse theory, where our universe is just one bubble among many, it's conceivable that another bubble universe bumped into ours in the distant past. A cold imprint that we now observe in the CMB. For our next destination, we don't need to travel to the edge of the observable universe. We just need to look inward, to the heart of our very own Milky Way galaxy. The galactic center, located about 27,000 light-years from Earth in the direction of Sagittarius, is a place of unimaginable violence and chaos. While our suburban spiral arm is relatively peaceful, the downtown district is a maelstrom of extreme physics. The density of stars here is staggering. Near the center, stars are packed millions of times more densely than in our region. They whip around the center at incredible speeds. The night sky from a hypothetical planet here wouldn't be serene, it would be a blinding, continuous blaze of light. But this light comes at a price. Massive, young, hot stars, old, dying stars. The region is flooded with lethal radiation. Gamma rays, X-rays, cosmic rays creating a deadly bath that would sterilize life. Supernova explosions are far more common in this dense core. Imagine a sky where a star exploding with the energy of billions of suns is a regular occurrence. At the very heart of it all, orchestrating this chaos, is a monster. A supermassive black hole named Sagittarius A. It contains the mass of over 4 million suns, all compressed into a region smaller than the orbit of Mercury. It is the gravitational anchor of our entire galaxy. Every star, every nebula, every planet, including our own sun, is on a multi-million-year journey orbiting this invisible behemoth, ruled by a monster of infinite gravity. We often think of planets as members of a family orbiting a parent star in a cozy solar system. But the universe is full of orphans. These are rogue planets, also known as interstellar planets, worlds that drift alone through the cold, dark void between the stars. They have no sun to warm them, no system to call home. How does a planet become a rogue? Most are thought to be ejected from their native systems during chaotic early formation. In the gravitational tug-of-war between giant planets and their star, smaller worlds can be flung out into interstellar space like a stone from a slingshot. Imagine Earth suddenly and violently cast out from the solar system. The sun would shrink to a bright star, then a faint one, then disappear entirely, leaving us in perpetual night. Life on the surface would be impossible. Surface temps would plummet to hundreds of degrees below zero, approaching absolute zero. Any atmosphere would freeze and fall as snow, blanketing the world in frozen nitrogen and frozen oxygen. The oceans would freeze solid, from the surface down to the seabed, entombing the planet in a crust of ice miles thick. If a rogue planet has a hot, geologically active core and a thick subsurface ocean beneath its ice shell, a silent, dark ice ball hurtling through the galaxy. From the absolute cold of a rogue planet, we now journey to the other extreme, a world being roasted alive. Meet WASP-12b, an exoplanet located about 1,400 light-years from Earth. This planet has earned the nickname the Hell Planet, and for good reason. It is one of the hottest planets ever discovered, a gas giant locked in a blisteringly close orbit around its parent star. How close? It completes a full orbit its entire year in just over one Earth day. The side of the planet permanently facing its star is tidally locked, meaning it's always daytime there. The temperature on this day side reaches an unimaginable 2,200 degrees Celsius, or about 4,000 degrees Fahrenheit. That is hot enough to melt any known rock or metal. The planet doesn't just glow with reflected light, it glows with its own heat, like a piece of charcoal pulled from a forge. It's so hot that molecules in its atmosphere are torn apart into their constituent atoms. The shape of this world is also horrifying. The intense gravity of the nearby star stretches WASP-12b into an oblong, egg-like shape. It's being pulled apart by tidal forces 1,000,000 times stronger than the forces our moon exerts on Earth. The star's gravity is so powerful that it's actively siphoning off the planet's atmosphere, pulling it away into a massive, swirling disk of gas around the star. WASP-12b is quite literally being eaten alive. It is losing mass at a rate of about 200 quadrillion tons per year. We are witnessing planetary destruction in real time. A long, beautiful tail of superheated gas streams away from the planet, feeding the star that is killing it. Scientists estimate that at its current rate of destruction, the entire planet will be gone in about 10 million years, a mere blink of an eye in cosmic terms. Our next stop is one of the most iconic images ever captured by Hubble, the Pillars of Creation. These are colossal towers of interstellar gas and dust in the Eagle Nebula about 7,000 light-years away. They look ethereal, like cosmic fingers reaching into space, painted in sublime hues of ochre, painted in sublime hues of blue. But do not be fooled. This beauty hides extreme violence and destruction. These pillars are stellar nurseries. Inside these dense clouds of gas, gravity pulls material together to form new stars. Starbirth is anything but gentle. As protostars ignite, they unleash ferocious stellar winds and intense ultraviolet radiation. That radiation heats the pillar surfaces, causing gas to boil away into space. This photoevaporation is actively sculpting and destroying the very pillars. The image is a snapshot of a war between creation and destruction. The dense gas provides raw material for new stars, but the first stars turn on their cradle and begin to tear it apart. The pillars are eroding before our eyes on timescales of thousands of years. There's another, even more violent threat. Massive stars live fast and die young. They end in cataclysmic supernova explosions. Evidence suggests a supernova may have exploded near the pillars about 6,000 years ago. Because the pillars are 7,000 light-years away, the light from that explosion hasn't reached us yet. We are, in a sense, looking at a ghost. We return now to the realm of black holes, but this one has a uniquely terrifying quality. We're traveling 250 million light-years to the Perseus cluster, a massive collection of thousands of galaxies all bound together by gravity. At the heart of this cluster lies a supermassive black hole, and this black hole sings. Not in a way you could hear with your ears, of course. Its song is a sound wave, a pressure wave, that propagates through the hot gas that fills the cluster. In 2003, Chandra detected ripples in the intracluster gas. Those ripples were pressure waves, in other words, sound. The black hole produces this sound through its activity. As it consumes matter, it ejects powerful jets of energy, creating immense sound waves that travel for hundreds of thousands of light-years. What's truly mind-bending is the pitch. It corresponds to a B-flat. It's about 57 octaves below middle C, trillions of times lower than the human ear can detect. One ripple takes about 10 million years to pass. The deepest note ever detected in the universe, a bass note of cosmic proportions resonating through a sea of galaxies. The energy behind it is horrifying, equivalent to hundreds of millions of supernova explosions. This sound shapes the entire cluster, heating gas and preventing new stars from forming. The black hole regulates the life of an entire galaxy cluster with its low, rumbling song. For our final destination, we confront a mystery that points to something beyond the edge of our known reality. It's a phenomenon known as the dark flow. For decades, astronomers have been mapping the motion of galaxy clusters. According to our standard models, these clusters should be moving more or less randomly, or expanding away from each other due to the expansion of the universe. But that's not what we see. On a very large scale, something is wrong. Vast collections of galaxies, stretching across billions of light-years, all seem to be moving in the same uniform direction at incredible speeds, up to 1,000,000 miles per hour. This collective motion is not random, it's a coherent flow, as if pulled by an immense gravitational force beyond the horizon of our observable universe. We can't see what's pulling them. We can only see the effect, a mysterious, large-scale dark flow. The source of this pull is nicknamed the Great Attractor. Early on, scientists thought it was a massive supercluster of galaxies, but visible matter there wasn't enough to account for the pull. The flow continues past that region, suggesting the source is even farther and more massive. The ultimate source appears to lie outside the sphere of what we can see. This is profoundly disturbing. The observable universe is the boundary of what we can ever interact with or receive information from. The dark flow suggests our neighborhood is influenced by structures of unimaginable mass we can never see. It's a gravitational anomaly hinting at a universe far larger and more structured than our view allows. The gravitational influence of other nearby universes in a multiverse scenario? We don't know. We've journeyed from the absolute emptiness of the Butte's void to the crushing density of a neutron star, from a planet being eaten alive to a force pulling our universe from beyond the veil. The cosmos is not a gentle, quiet place. It is an arena of extremes where the laws of physics manifest as forces of unimaginable horror and violence. These 10 locations are not fantasies, they are real destinations on the cosmic map, each one more terrifying than the last. They challenge our sense of safety and our place in the universe. The beauty we see in the night sky is real, but it's a beauty born from chaos. We exist in a brief, peaceful interlude in a quiet corner of a violent city. The awe of the universe is not just in its grandeur but in its terror. Understanding these extreme places doesn't diminish the wonder, it deepens it. It forces us to appreciate the delicate and perhaps temporary nature of our own existence on this fragile blue planet. The universe is not for us, it is not against us, it simply is, and its indifference is perhaps the most frightening thing of all. So which of these cosmic horrors chilled you to the bone? Was it the existential dread of the great nothing or the physical annihilation of the event horizon? Let me know in the comments below which place scared you the most. And if you want to continue exploring the beautiful and terrifying secrets of our cosmos, be sure to subscribe to AstroAwe and ring that notification bell. Remember, the universe is more terrifying than any horror movie. Until next time, keep looking up.